Okay, this is part two where I'm just going to go over a few of the examples. Okay, so when we look here at number 10, because part one covers the within between. So when we look here at number 10, we see that the triangle look like it's rotated. Well, you could take a sticky note and sticky notes will be available to you to rotate this, or you can just redraw it yourself if you understand how the right angle needs to be in the corner, or sometimes you can just look at it and determine what goes with what, because that's what's important. As long as you can identify with what goes with what, you're fine. So, for example, I know that this slant will go with this slant. I know that this bottom will go with this bottom. And I know that this side will go with this side. If you can do that, you don't have to rotate it. But if you know you struggle with that, and this color pencil is available to you, and some highlighters, but then go ahead and do that. So after you saw part one, you understand between and within. So the first thing I'm going to do is do what's the between, because that's something that's common to us. So the method I'm going to use is the between. So what that means is that I'm going to take one corresponding side from each figure, and then set it equal to another corresponding side from another figure. So I'm going to start with the X from this side here. So I'm going to say X over 4, because those are corresponding. So X and 4. And I'm going to set it equal to, I guess I'll use blue, 4 and 2. So I have to start from exactly which triangle I started with originally. So 4 and 2, and that was from blue. And now I would solve like we normally solve anything. I can cross multiply or scale. So if I cross multiply, I know 4 and 4, that's 16, is equal to 2x, well, 2x. Divide both sides by 2, and x here will be 8. So this missing side here is 8. I hope that was clear. All right, let's go to the next one. Okay, now for number 12, you can do this one on your own. If you look at it, you just have to rotate it. On here, I'm going to use the within method. And so for this one, you will see that because it's a rhombus, whatever's this side is also this side. Some things we got to just know the attributes ourselves. So what that tell me is that whatever I say, this is blue. So I know in reality, those are going to be like very similar, or I mean the same. And you can look at the angles to make sure that they look alike, to make sure you're lined up correctly. So if I do within, that means I'm going to only take from within one shape first, and then I'm going to do the same sides corresponding. So what I'm going to use here is the 3 and x. So I'm going to say 3 over x. So that's a blue, then a green, and I'm going to set it equal to the same ones over here. Now, because these are the same, I could say 4.5 here and 6, but it means the same thing. So I'm using the same angles, 4.5 over 6, so that I'm still respecting the fact that I'm doing blue and then green. And now we can solve this by either using um, whichever method that you desire, because this is a between. So I can cross multiply or I can scale. This is a cross multiply, definitely. So 4.5x is equal to, what's that, 18? I'm going to divide by 4.5 on both sides. And that means x then is equal to 4. All right, I'm going to move on to do one of the harder ones. Now for this one, if you notice, it's still just two triangles. You can turn them with paper and look at them that way, or just identify what goes with what. But I believe you'll be successful. But I want to look at 15 because sometimes this gets us a little confused, and I don't want that for you. If you look here at 15, you will see that there's two triangles. Now, the way I will tell you to do this is to take out one of the triangles separately. So I'm going to remove this smaller triangle up here, and I'm just going to draw that here. And I'm going to put all the measurements that go just for the small triangle. I know it's x, 2.5, and 3. That's just the small triangle. Now for this big triangle, I no longer am looking at the small triangle. So I need to know what the measurement is for this whole side for the big triangle. Now they don't give us this small side here, and that's okay, because then we just won't use that side. We will use the sides that we do have everything on. So they gave us the 9 at the bottom, and for here, I know I have to say 4.5 plus 3, which is 7.5. So this side really is 7.5. So this whole side is 7.5. So now we did one between, we did one within. I'm going to do between again. And I'll show it with both. I'll show between and within so you can see the difference. So between says one from each one. So I'm going to use 7.5 because, again, now I have them separated. I can identify what goes with what. I'm really only going to use these two sides, especially since I don't have the rest of that other side. So, I mean, you can identify it, but we're not. Okay, so I would say 7.5 goes with 3, and that's equal to 9 going with x. And for within, I can say 7.5 goes with 9 because it's a side to a bottom, and that's equal to 3 going with x. And x is green, 9 is green. And these are blue. And I'm doing this so that you can know exactly where I got it from if you want to come back and look at that. And now I would just solve it. So I'm just going to solve it. Yeah. That's 7.5x is equal to 27. When I divide by 7.5 on both sides, I get x is equal to 3.6. Now, when I go over here and I do the same thing, if you notice, I'm getting the same thing. It just might be a different order. So 7.5x is equal to 27. Divide by 7.5. X equals 3.6. All right, that was your notes. Hope it makes sense. And you guys are responsible. Put this in your notebook. And you're responsible for both sides. It too is your homework.